What is positive feedback? Positive feedback resupplies the diminished supply. So basically, it's very powerful. Now, again, you must ask yourself, what is positive feedback? Well, positive feedback replenishes the diminished supply. Basically, it's really powerful. What is negative feedback? Negative feedback, it stops creating something to diminish the supply because you've got so much excess supplies that you're like, well, what am I going to do now? So it's basically like this. Plant here. Man, plant, you got a lot of water. Why don't you stop getting so much water? Okay, plant, you don't have enough water. Go back in. Okay, you don't have enough water. You have too much water. There's negative feedback for you. Now, again, you must really ask yourself this twice. What is negative feedback? Well, again, I must say, negative feedback increases or diminishes the production rate so that you don't have too much excess supply. So, the cell's ultimate product is itself. So, like this cell right here, you're like, okay, I've got this cell, but come on, I gotta make more. So, it's gonna pull out another cell. You have two cells now, and it just keeps happening over and over and over again. But really, guys, you really have to ask yourself this question. The cell, what is its ultimate product? Well, you see, the cell's ultimate product is itself. Like this
Allosteric enzyme. It is an enzyme that can do two things. It has a working site and a regulatory site. And it monitors the amount of product you have, so if you have too much, it stops. Yes.
Hi, I'm an allosteric enzyme, and I will be making a shovel today with my invisible friends here. Sadly, they don't like me, so they're invisible. Anyway, so I will be passing this around to make a shovel. They will put all the parts together onto it to make a shovel. So here you go, man. Here you go. Like, just add something to it. Thank you. You add something to this. Thank you. You add something to this. Okay. Now, here we go. Here's the shovel. Oh, but wait. I got too many shovels here. I'm gonna stop working. Sorry guys, we gotta stop working. Okay guys, we can start working again. So, here's another part. Build onto it. Thank you. Here's another part. Thank you. Here it is. Thank you. And here we go, guys. We got this shovel again. Thank you. But unfortunately, we got too many shovels over here. Just stop parking.
Allosteric enzyme. It is an enzyme that can do two things. It has a working site and a regulatory site. And it monitors the amount of product you have, so if you have too much, it stops. Yes.
Okay. The internumen wasp infects the spider, and the night before it dies, it forces the spider to make a platform. Makes a platform, and then the larva slowly eats this spider, and then kills it, eats it alive. Okay. The internumen wasp infects the spider, and the night before it dies, it forces the spider to make a platform. Makes a platform, and then the larva slowly eats this spider, and then kills it, eats it alive. Just switch what I said there.
How does the internumen wasp larva get the orbiting spider to build its platform? It infects the spider, and it slowly eats him, killing him. And the night before it dies, it requires him to build a web, a platform, for this wasp larva to live on. Yes. And then it eats it, and it uses the body for food. It's eaten, it's dead, and then it slowly eats it, the whole thing, to go up and live. That's it. Cut. So, lockstep sequences. First, the spider releases a strand into the breeze. Once it catches, it senses it up at both ends. Look at that sensing. Walk across, paying out a second, looser strand. Attach at both ends. Step to the center of that strand and drop a third line, forming a Y. If-then rules. Measure the angle. Measure the angle of each radial. If an angle is too wide, add another radial. Trial and error. If the web weighs too much in the wind, try adding weights to it. If this doesn't work, abandon the site. Simulation. Make a preliminary sketch of the spiral using temporary weapon. Then retrace your steps. Make a permanent spiral, measuring carefully as you go. Eat the original sketch. Lockstep sequences. Release a strand into the breeze. When it catches, paying out a second looser strand. When it catches, cinch it up and attach it near the end. Walk across, paying out a second looser strand. Attach at both ends. Slide to the center of that strand and drop a third line, forming a Y. If-then rules. Measure the angle of each radial. If an angle is too wide, then add another radial. Trial and error. If the web sways too much in the wind, try adding weights to it. If this doesn't work, abandon the site. Simulation. Make a preliminary sketch of the spiral using temporary weapon. Then retrace your steps. Make a permanent spiral, measuring carefully as you go. This is how dictodiscoidium is an elegant example of the power of molecular communication.
Yo, what's up? Get together. We're together.
Ah, yes. This
The light
organism.
right there, as you can see.
This organism, which starts out as a disconnected group of separate individual cells, becomes a coordinated cellular community. And that's how it provides an elegant example of the power of molecular communication. And just to say that one again, this organism, which starts out as a disconnected group of separate individual cells, which, in response to a source of food, becomes a coordinated cellular community. This has been Jackson. How does a bacteria move itself? Well, it runs, and it tumbles, where it spreads itself out and it turns, like so. And then it runs again, and it keeps running and tumbling until it gets to a concentration of food. And when it gets closer to that food, it tumbles and runs more often to stay within that food. Yep, that is a self-correcting process, and how it moves in relation to a food source. So just to repeat that one again, it runs, and it tumbles by spreading its arms out and turning towards food. Oh, whoop, food over there now, and I was gonna run again to get to that food.
Shoot.
What are allosteric receptors? Allosteric receptors are embedded in cell membranes. Each type of receptor matches a particular signal molecule. And when a molecule fits, the receptor changes shape, releasing an internal signal. This triggers cellular changes. What can a simple hormone do, you might ask? Well, a simple hormone molecule can travel through the bloodstream to turn on chemical activities in cells all over the body. That's right, you heard me right. I said allosteric receptors are embedded in cell membranes. Each type of receptor matches a particular signal molecule. When a molecule fits, the receptor changes shape, that releasing an internal signal. This triggers cellular changes. And for hormones, you know what I said? Well, I said that a simple hormone molecule can travel through the bloodstream to turn on chemical activities in cells all over the bodies. Like this, the freshly cut grass. It's releasing so many smells.